All right, so this video is about the derivative of the arcsine function. And get a full screen. And there's some foundational work that needs to happen. We've got to make sure that's in place. So let's get right back to the beginning, which is, oh, thought somebody was making a call here. So the language, trigonometric language, the sine of an angle gets us a ratio. Okay, so this command requires an angle, and angles can be written either in degree measurement, which most people are more familiar with when they begin the study of trig, but trig is more likely worked with radian measurements, radius lengths. So yes, what is a radian? I want to suggest you look at that video, because if you're not sure what a radian is, it's going to hamper your understanding of the whole study. And that is a concept that students have a lot of trouble with. You ask a typical high school student what a radian is, and you're unlikely to get an answer. So it's very important, I think, to look at that video. And so the first thing we're going to do is we're going to find the cosine of the arcsine of x. Again, language is important. Arcsine begins with a ratio. Well, that's arcsine language. That's a ratio. Doesn't look like a ratio, but every number is divided by 1. Can be divided by 1. We just don't show it. Well, I'm showing it now so that we can get a picture. All right, we're trying to find the angle whose arcsine picture is x over 1. So let's get the arcsine picture going. There's x, there's 1. I'm looking for that angle. Now, I can't tell you what it is unless I know the value of x. If x was a half, I know the arcsine of a half comes from 30 degrees or pi over 6. All right, but this is just in general. And now I'm looking for the cosine of angle A. Okay, well, I can see that. That's Pythagoras. All right, that's just a little Pythagorean theorem where that's x squared, that's 1. Well, I did a pretty good job that time. And so what's this area? That area is 1 minus x squared. And so what is that length? The square root of 1 minus x squared. So we got to be able to see that. Need some practice with that. What would happen if this was 2x? Hopefully you'd come over here and you'd write 2x. And therefore that would then become the square root, the cosine of this would be 1 minus 4x squared. Hopefully you're getting the gist of that. All right, so that's important to know. Language. The sine of an angle gives us a ratio. The arcsine, or the sine inverse of a ratio, gives us an angle. And we'll elaborate on that as we go along, as in right now. So, again, just highlighting the language. So arcsine of x, that's a ratio. Okay, and the ratios, if we looked at the inverse sine function is concave down in the first 90. The arcsine is going to be the inverse of that, concave up. And the same thing with this quadrant here. And if I graphed the entire sine function, its inverse, the whole 9 yards, it would look like this, and that's not a function, right? We're not getting that one-to-one relationship. So mathematicians have basically taken the arcsine function and restricted it to be ratios from 1 to -1. We pass a half. We pass -1/2. And you're on this pathway. Now that pathway starts, we'll use degrees, 0 degrees, and goes up to 90 degrees. We're used to saying the sine of 90 is 1. We're not as familiar with saying the arcsine of 1 is 90. And that gets converted into radians, more than likely. Okay, so where am I on the circumference of the circle? Pi over 6 radius lengths, which is approximately 0.52. I got a better approximation a little further along. Okay, so that's a radius length. Where's root 2 over 2? Pi divided by 4. Okay, so That's 0.71 radius lengths. I think pi over 4. I'm not sure I memorized that. I know root 2 over 2 is 0.71. So I'm not sure what that is as a decimal. But the main thing to pick up is that we're not going to 270 degrees. There's no pathway here. This is negative 90 degrees or negative pi over 2, negative pi over 6 halfway down. These are all about the circumference of the circle. You give me a ratio, start with a ratio. I'll give you where you are in the circumference of the circle. And the ratios are over here. 0, 1/2, 1, negative 1/2, negative 1. And what used to be concave up for the sine, concave down for the sine function, concave up for the arcsine. All right, foundational stuff still. Now we turn to the calculus. So how do you show the derivative of arcsine of x? Well, we use implicit differentiation. Isolating x, I'm going to use the inverse function over here, sine inverse, forgot to write that, sine inverse of y. Okay, so that's a ratio. The arcsine, well, it's going to become an angle. So the sine function is the inverse of arcsine, excuse me. I told you, once I start talking, I forget what I'm doing. So I wrote this down without talking, I was fine. So the sine of y equals x. So therefore, the derivative of the sine of y with respect to the change in x equals the derivative of x with respect to x, which equals 1. All right, and cosine y times dy dx is the implicit differentiation. So therefore, isolating y, isolating dy dx, multiplication becomes division. But this is a picture. All right, so we got to do the picture here. So this cosine language means y is an angle. So here's y as an angle. Okay, and that angle gives us the ratio x to 1. So we're backing up a little bit, which is very helpful because now I can find the cosine of y. We just did that work a little while ago. And in this case, it's 1 minus x squared. Okay. And remember, that's a ratio, and that ratio is opposite over hypotenuse for the sine function. All right. So where are we going with this? Right, so let's actually look at the arcsine of a half. I wanted to do it numerically. Right, so the arcsine of a half, derivative we just found out is this. That's the derivative. And if you plug in 1/2 and you square it, you get a 4th. Which means that we have the square root of 3 over 4, right? 1 minus 1/4 is 3/4. So why don't I just keep going here? Which is equal to 1 over the square root of 3 over 2. And dividing by a fraction, you multiply by the reciprocal, and you get 2 over root 3, which is 1.15470. And that's the derivative of the arcsine function at a half. So I decided to just play with some numbers. And I went to the calculator. And I did the sine inverse of 0.5001 minus the sine inverse of, instead of writing 0.5, I wrote a half to make everyone see that that's a ratio. Okay, and this is a little bit bigger than a half. And so I got a little bit of a change on the arcsine function, which I drew over here again, one more time, got Rene working. So here's a half, and I want to know how it's changing at that instant. All right, we want to look at that from a numerical standpoint. We just looked at it at a graphical to see if we can believe what we're looking at. And so I crunched the numbers, and I came up with 1.1547 when I moved the decimal places 3 units to the right. The exact answer is 2 over root 3, but I decided to put that in the calculator. That came out to be 1.15470. 1.15470. I would say there's pretty good accuracy just over that little interval. It's not exact because I'm doing a one-sided limit. All right, and therefore they're going to be off by a little bit, but I can trust those numbers now. I'm seeing the graph, I'm seeing the equation, I'm seeing where it comes from. The only thing I didn't do, and I don't think I will at this point, was try to prove cosine y. I'm kind of looking at, where am I here? Where did I show it? Oh, trying to show why that's one. That's the only thing I haven't shown numerically here. I wish I had, but I didn't do it. But we have looked at simpler situations in earlier videos, so maybe you can extrapolate. All right, so that's just going to go into the calculus play set. And hope I didn't make any mistakes there. I did a couple of times because it's awkward working with angle to ratio, angle to ratio, angle to ratio for so long. To go backwards to arcsine of a ratio is an angle. It's easy to get dyslexic. Same thing with e to the x and ln of x once you start working with those numbers so much. So hope that helps somebody. And if I misspoke in any point, I got people checking, right? Okay, I like ending this now saying, stay safe, stay warm. All right.